Welcome to our presentation on prototype patterns by Jordan Jones and David Durant. The prototype pattern is fairly simple and straightforward in concept. The idea behind the pattern is to create a new object at runtime. The object can then be cloned and modified as needed. This allows for the bypassing of the operator new, as it can often be more costly to create brand new objects than to clone a predefined object. This pattern often requires the use of a registry that keeps track of prototypical objects, and the use of a factory method to connect prototype objects. As shown in the figure, a good example of the prototype pattern in real life is a single-celled organism. It starts off with one cell. This cell, rather than creating another cell from scratch, it takes its own structure and duplicates these characteristics into a second exact copy of itself.
This example is courtesy of journaldev.com. In this example, we are reading a list of employees from a database, and then we are going to add and remove names from the list. Instead of having to make a database call to get the information each time, we'll just clone the initial employee list and edit the data in the clones. As you can see, we create a basic list with 4 names in it: Pankaj, Raj, David, and Lisa. Notice the clone method is overridden to allow us to do a deep copy of emplist. This way, we create a clone that is independent of the original, and any changes we make to the clone will not change the original. There's another type of cloning called shallow cloning, where you don't copy every object type. Shallow cloning is the default implementation in Java, even though deep cloning is usually the preferred method. Here we test the prototype pattern. We begin by creating a new object, emps, of type employees, then load the data into the object. We then create 2 new objects that are cloned from the original object, emps new and emps new 1. Next, we'll add the name John to emps new and remove the name Pankaj from the second object. If all works as planned, we should get an emps list that reads Pankaj, Raj, David, Lisa, an emps new list that reads like emps, but with the addition of John, and an emps new 1 list that reads like emps, but without Pankaj.
Being a simple pattern, there are only a couple noteworthy advantages to using the prototype pattern. Rather than creating a brand new object every time, it creates one at runtime. This can increase performance, especially on large projects. After the creation of the base object, it can be cloned however many times as needed. This is an inexpensive way to initialize objects as the operator new isn't required.
There are some downsides to using the prototype design pattern. This pattern is not for every project and can be overkill in projects that use only a few objects and that does not have an underlying emphasis on the extension or prototype chains. This kind of pattern is best if you've got quite a few objects that are all similar in nature. Another downside is that it hides concrete product classes from the client. And lastly, each subclass of prototype must implement the clone operation, which isn't always the easiest thing, especially when the classes under consideration already exist. It can also be difficult when the class's internals have objects that don't support copying or have circular references.
As most of the benefits to prototyping are with memory and performance, it can be difficult to know when to utilize. It is best when performance is a concern and more flexibility is needed. As for use with the elements table application, this pattern would be good to keep in mind as possible solutions to performance issues. However, it is best to do so with caution, as this pattern can add a level of complexity to a project that can be undesirable, especially when the project is small. Thank you for watching our presentation.